The next measure of central tendency that we're going to look at is the mean, which is more accurately called the arithmetic mean because there are different types of means out there. There's an arithmetic mean, a harmonic mean, and a geometric mean. We are going to focus on the arithmetic mean in this course, which is also one that you are probably familiar with. So how you find the mean is given a set of numbers, you add them up, and you divide by how many numbers there are in your data set. That's how you find the mean, but what is the mean? Well, the mean is going to be the balancing point or center of gravity of your data set, where the values to the left are perfectly offset by the values to the right. So to highlight what's going on with that, I have these two different data sets right here, so I'm going to zoom in on these. Both of these data sets have a mean of 9.5. So let's explore why the mean is 9.5, and also we're going to talk about some of the differences of what's going on in these two data sets. So for this first data set with the mean of 9.5, now this is a different type of graphical display that we didn't cover earlier in this course. This is called a dot plot. So each one of these dots represent a data value that would be in my data set. So I have data values of 5, 8, 9, 10, 12, and 13. So given that data set with those 6 values, their mean would be 9.5. Let's find out why. We are going to find the distance the data value is from the mean. So this data value right here is a distance of half a step to the left. This data value right here has a distance of 1.5 to the left. And this data value out here would be 1, 2, 3, 4.5 steps to the left. So overall, the pull to the left of these data values would be 4, 5, 6.5. Okay, so that's the pull to the left of the mean of these data values. Now let's go and find the pull to the right. This point has a pull of half to the right. This value out here has a pull of 1, 2.5. And this value out here has a pull of 1, 2, 3.5. So overall I have 5, 6.5 cumulative pull to the right. And that's exactly what the mean is supposed to do. It is supposed to be the value such that the pull to the data values, how they pull to the left of the mean, is perfectly offset by the pull to the right. Now here is a different data set down here that also has a mean of 9.5. And let's go explore what's going on with the offsets left and right of this data set. So each of these two data values right here have a pull of 0.5. And this value out here is a pull of 1.5. So cumulatively on this side, it has a pull of 2.5. Going over here, these two values have a pull of 0.5 to the right. And this value over here has a pull of 1.5 to the right. So cumulatively on this side, it has a pull of 2.5 to the right. So the values that are going to be on the left are perfectly offset by the values on the right. So when we calculate the mean, it takes into account exactly where every single data value is. So for instance, if I were to take this data value and I were to move it over here, that's going to affect the offset to the right. So either, and if I'm not going to move any other data values, then this mean is going to have to shift to compensate that greater pull to the right. Now both of these data sets had a mean of 9.5, but something very different was going on in the data values. In this second example, these data values were actually symmetric. How they rested over here to the left is a perfect example of how they're over here to the right. So, I mean, these distances were the exact same going to the left and the right. Also, these values are clustered closer to the mean than what's going on this one. So on this one, the values were kind of all over the place. They had different distances, but the cumulative distance offset by the left was equal to the cumulative distance offset by the right. And these values are more spread out from the mean. We're going to take a greater look at the spread in the next section. So there is an example about what we mean, or what we're implying when we say that the mean is the balancing point of the data set. Now when you're going to compute the mean, we use the symbol, looks like that, and it's pronounced X bar. If you're finding the mean of a sample. Okay, we use this symbol, and it looks like a U with a tail on it, and we pronounce this mu for the mean of a population. So this is actually a Greek symbol. When we go to find calculations relating to population data, we normally use Greek symbols to notate the answer. When we go to find calculations from sample data instead, we will use a kind of an alternate symbol set. So we notate the answer differently whether or not it's the mean of a sample versus the mean of a population. Now for the most part in this module, you can assume that the means that you're finding are going to be means of samples unless you're told otherwise. So then your final answers will be notated using this X bar notation. So as an example, finding the mean, the following data represent the travel times in minutes to work for all 7 employees of a startup web development company. So the times are 23, 36, 23, 18, 5, 26, 43, and 18. We're going to calculate the mean and round to the nearest tenth as needed. Now in this particular case, because they're saying that this is the data for all of the employees of the startup company, this then represents population data. Okay, if it was for a sample of employees for maybe a much larger company, then if it was a sample, then I would use this X bar notation. But because this represents the data for all of them, we would notate our answer using this mu symbol. So to find the mean, which in this case is going to be notated with the mu, we would add up all these numbers. So 23 plus 36 plus, okay, and then through these last values, and then we divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8 values. Adding all these numbers up, we get 192. So then 192 divided by 8. In this case, this actually divides nicely, so I'm not going to need to do this rounding rule. So I'm getting that the mean of this data set is 24. And then the units on my answer, this would be minutes.